Hello, I am Emah Cassidy, and I will be doing my Chemistry 251 honors option on influential women in chemistry. First off, and probably most notably, I will be discussing Marie Curie. A little bit about her is she was born November 7th of 1867 in Warsaw, Poland. She later gained her doctorate of science in 1903 and was the director of the Curie Laboratory at the Radium Institute of the University of Paris. She was the first woman to win a Nobel Prize, and she later died on July 4th of 1934. Marie Curie had great advancements in the field of chemistry, and most notably, she discovered both radium and polonium through studying uranium in 1898. And she did this through studying a material called pitchblende, which was kind of a combination of uranium and what some thought was other radioactive material. And once she kind of extracted the radium and polonium from this pitchblende, what she really wanted to do was chemically isolate the radium, which wasn't previously done. So she worked diligently by refining several tons of this pitchblende, and through that she was able to isolate just a measly 1/10 of a gram of pure radium chloride in 1902. But she still wasn't satisfied with this. She wanted to isolate the pure radium, and she was able to do this in 1910. But unlike the other two elements, uranium and polonium, radium is not freely occurring in nature. With her work with radium and polonium, she had great scientific advancements in the field of chemistry and medicine. For example, polonium is used for eliminating static electricity in machinery and is used for removing dust in photographic film. And more significantly, radium was used post-World War I to treat cancer and is still used today in some radiation treatment therapies, more specifically in prostate cancer. In the early 20th century, radium kind of had a big boom commercially, and it was used in toothpaste, hair creams, foods, paints for watches, aircraft switches, and clocks. And it was initially thought to be this really healthy substance that kind of was a cure-all. And as you can see on this image, right here, as you can see, this woman has these needle-like things in her chest, and these are known as radium needles, and they were glass needles that were filled with radium that were thought to kind of be a cure-all for any diseases, and like this woman here with the breast cancer. And radium was used in the 1900s commercially up until the 1970s when its adverse side effects were starting to be noticed. So radium then was heavily restricted in its use, and we can see even in Marie Curie how its adverse side effects really had a reaction. And we can see this because Curie died from leukemia, and it is likely speculated that her leukemia was brought on because of her many years of exposure to radioactive materials, like her work with the radium. Next, I will be discussing Ida Noddack and her contribution to chemistry. She was born February 25th of 1896 in Wessel-Lockhausen. She received her doctorate from the Technical University of Berlin in 1921 and was nominated for 4 Nobel Peace Prizes. Although she never received a Nobel Peace Prize, in 1934 she received a coveted Swedish Chemical Society award that was very prestigious, and she later died in 1978. Her major contribution to chemistry came in 1925 when, alongside other scientists, she discovered how the atomic number of an element could be deduced. And that was from the use of spectrum rays that nuclei from an element emitted to give its atomic number. And through her work with the atomic number, she was able to discover rhenium, which she is most accredited for, and she did this in 1925 as well. And rhenium is one of Earth's rarest metals. It is resistant to deactivation, which means it doesn't corrode like many of the other metals that we see and use today, for example, iron. Its uses include filaments for spectrographs, ion gauges, flash lamps for photography, X-ray machines, and electrical contact metal. Later in her career, Ida, in 1934, published the paper called On Element 93. And in this paper, she suggested the ability of the nucleus to break apart, and she was kind of referring to isotopes in this paper. Her work on this paper was initially ignored by many accredited scientists. They didn't think that this idea had any validity, and they thought it was kind of an out there idea. But when we look back today, we can realize the significance in her ideas as being one of the first expressions of nuclear fission. Next, I will talk about Isabel Karl and her contributions to chemistry. She was born December 2nd of 1921 in Detroit, Michigan. She studied physical chemistry at the University of Michigan and was the recipient of the Navy's Superior Civilian Service Award, the National Medal of Science, and many more, and she died on October 3rd of 2017. Her scientific contributions are many. Alongside her husband, Isabella Karl developed techniques to extract plutonium chloride from plutonium oxide. More significantly, though, she helped to determine the structure of complex biological molecules, including proteins. And she did this through using electrons and X-ray diffraction. And you can see this kind of X-ray diffraction, I guess you would call machine image on the right. With her work with X-ray diffraction, she was able to publish and was the first to publish the structure of steroids, alkaloids, toxins, and peptides. And this was very important for the field of medicine in that this technique allowed for the development of many new pharmaceutical products and medicines. And that was because knowing the structure of the medicine allowed for scientists and doctors to know how the medicine was to interact with the human body. And this led to the development of many medicines that were to cure many common diseases. And while these last three women were basically the start of women in chemistry and had such notable contributions, we see that women in chemistry is still so important today. And some notable women that are today working in the field of chemistry are Clarice Phelps, Tu Youyou, Emmanuelle Charpentier, and Jennifer Doudna. Clarice Phelps is a young chemist who helped to synthesize element 117. And while this element is not naturally occurring, she has advanced the idea that the periodic table is not in fact complete and that there are more elements that are to be discovered. Tu Youyou is the recipient of the 2015 Nobel Prize for her research in plant compounds. And this, her research in plant compounds and their structure and their chemical structure allowed her to successfully create a treatment for malaria. And she has actually since created 2 successful treatments for malaria with her research in plant compounds. Later and more currently, Emanuela Charpentier and Jennifer Doudna are the Nobel Prize winners for the CRISPR-Cas9. And the CRISPR-Cas9, basically what it does is it corrects a mutation that causes sickle cell anemia, and it does this by splicing the DNA and removing the part of the DNA that causes sickle cell anemia, so that an individual doesn't have sickle cell anemia and doesn't pass it on to their offspring. And currently, they are working to develop technology to detect COVID-19 and other viruses. As we can see, women have had such an immense impact on chemistry, and their impact will last forever. Thank you so much for listening with me and learning about important women in chemistry. Here are my references. Thank you.